Hey everyone, so welcome back to problem number 2 for day 1, and today's problem is longest substring without repeating characters, which is problem number 3 on LeetCode. And this problem states, given a string S, find the length of the longest substring without duplicate characters. Okay, let's move to the dashboard and we'll try to investigate and answer this problem. We have been given a string S and we have to determine, hey, what is the length of the longest substring that we can have without any duplicate characters. When I tell you to look at or visualize substring, always assume that those substring fits inside some window, okay? So in nutshell, we have to determine the length of the maximum window that we can have. And this window, it will contain the substring that is required by the problem, okay? What can be the brute force approach for this problem? The brute force approach for this problem can be to generate all the possible substrings that we can have and to determine all those substrings that do not have any duplicate characters and compare each and every length of those substrings with each other and determine the max length out of that. But generating a substring is of order of quadratic task and something it is something we cannot afford, right? Because it of time complexity constraints. So what can be the optimal approach for this problem? The optimal approach for this problem, every time you have been given a problem including substring, try to think in the direction of sliding window. And when we think in the direction of sliding window, more often than not, our time complexity revolves around linear time, order of n time, okay? So for this problem, we will be tackling this using sliding window approach. Now, as I told you earlier, our sliding window problem will have two pointers, a left pointer and a right pointer, and we try to expand the window to the right using the right pointer, and we only move left pointer when our condition is violated. Okay, let us go through that diagram. We have two pointers, left pointer and right pointer, and initially both of them are at index 0. For this problem, we will assume that we have an empty set. A set is nothing but a set is like a container that contains unique elements. So every time you enter duplicate elements, those duplicate elements will not be counted because it already, if it has already, identical elements as similar to the new element that you're entering. Okay. So initially both pointers are at index 0. What we notice? We notice A is not in the set. So let us add A into the set. Okay. And then we move right pointer to this point. What do we ask? We say, hey, is B in the set? We say, no, B is not in the set. So let us add B in the set. And to this point, since we added B, what is the max length? So the max length is 2, correct? How are we comparing length? How are we computing length? We are computing length by R minus L plus 1, okay? Why plus 1? Because the index was 0, so 1 is offsetting that, okay? Now we move our right pointer again to C and we ask, hey, is C present? No, C is not present. Let us add C and the max length of our up to this point, it becomes 3, correct? And we increase R again and we ask, hey, is A present? We notice, hey, A is still present. So in that case, our condition is violated. So in that case, we move our left pointer by 1 and then we delete A, but since we are at R, which is pointing to A, we add A back again, okay? And the new length will be up to this point, right? So on and so forth, we will try to adjust and increase both our pointer. And by the end of this, by the end of the entire traversal, you will notice that the max length for this case is 3, which is our actual answer as stated by the problem example. So let us go through the sliding window code. We will declare the left pointer as a verb in this case here, and the right pointer is an iterator that is going through the loop, and the loop will iterate across the length of s, which is the string. So this will be order of n time complexity, and we'll also have a max length variable, which is something that will return once we exceed the main loop, as you can see here. And we also have a set. I will come back to this problem after we walk through this entire code. Okay. So once we get inside this main loop, we ask, hey, is the right pointer value or right pointer, is it within the set? If it is not, if it is present in the set, in that case, please remove the value present at the left pointer and increase the left by one. Okay, why are we doing this? We are doing this because if you go back to the day one problem and problem number one, we are considering as of left as a noise, and we are thinking if we remove that, maybe our our substring will get rid of the duplicate. Okay, so we try to remove the value present at as of left, and we increase the left pointer by one, and we keep on cycling this until and unless we get rid of all the duplicates. Okay, once we come out of this while loop, we add the right pointer value present at the right pointer into the set, and we make a comparison with the max length, and we determine whatever the max length was, and we feed it into max length, and once we run out of the entire length of the s, we return the max length. Okay, so as you can see, the time complexity is order of n, and strings, as stated in the problem description, it can be either English alphabet characters, preferably lowercase characters, or any other symbols. Okay, so these symbols, I'm assuming it will be order of less than 1000, which is again a constant for us. Okay, so this was the basic and easy walkthrough of the code for this problem. Now, what are the pitfalls that we need to avoid, the edge cases that we can take care of? One of the edge cases that we can take care of is that our strings must not be empty. If it is empty, so we have to deal with that. Second one is that what if every single characters in our string is identical? So we have to deal with that as well. And one of the thing that we need to keep in mind is we need to keep on updating our max length every time we can. We need to increase the left pointer within this while loop, and we need to make sure that we are getting rid of the duplicate through this condition, okay? And by this deletion within the set. All right, so these were the things that we need to take care of in our mind. Now let us move back to LeetCode, where I will submit the solution for this problem. So I am at LeetCode right now. I will simply copy and paste my solution, and I will just run it. And as you can see, it gets submitted. Oops. As you can see, it gets submitted. Why is it not working? Okay, yeah. As you can see, it gets submitted. And yeah, so that was it for today's problem number 2 for day 1. Now, after this, we are going to problem number 3, which will be a hard problem. Let us